Hello, dear students. This is your Jagan sir. Welcome back to our Physics with Jagan sir YouTube channel. And we have successfully completed 10 classes on kinematics. And this is the 11th class. We are going to discuss relative motion in 2 dimension. And relative motion in 1 dimension we had already covered in previous classes. And in this class, we are going to see relative motion in 2 dimension. 2 dimension. And see here, the first important point is this concept is little bit logical and a little bit analytical. Means more thinking process is held while we are solving this type of problems. To avoid confusion, I am going to split the relative motion concept in 2 or 3 classes. And the initial class today we are going to discuss, and tomorrow we will continue the same relative motion concept in session 2. Right? Now, here first concept is relative motion in 2 dimensional. Relative motion in 2 dimensional. See here, first point, let us assume let us assume here a point A is present, here a candidate is present, and here one more candidate is present, let his name is B. Here one more candidate is present, let his name is C. Right? Now, position of A with respect to C is like this, and which is equals to R A C, position of A with respect to C. We can write like this. And second point here, position of A with respect to B, that is R A B, position of A with respect to B, R A B, right? Like this. Then third one, position of B with respect to position of A with respect to B, position of B with respect to C. Now, position of B with respect to C is equals to RBC. Then it is forming a triangle of vectors. Now, by using closed loop concept, we can write RBC plus RAB is equals to R minus of RAC, because this vector is representing in the upward direction. Instead, if it is representing in the downward direction, it will form a closed loop that will give the resultant of 0. But here, it is representing in the opposite direction to the closing the loop. That's why I am keeping it as negative, is equals to 0. Then RBC is equals to RAC minus RAB. This is position of B with respect to C, right? That is RAC minus RBC. Now, by differentiating, we will get drBC by dt, drac by dt, drab by dt. This will be VBC, VAC, VAB. This is relative velocity of one object with respect to other object, right? Similarly, again by differentiating, that is dvbc by dt, dvac by dt minus dvab by dt. Then this will gives us acceleration of B with respect to C, acceleration of A with respect to C, acceleration of A with respect to B. This is how we can apply relative motion concept with of one object with respect to other object. And it is a very small concept. But solving problems over this concept is little bit logical, critical, and analytically we need to apply more conceptual understanding while solving these problems. And before we are going to solve some critical problems, let us try to understand the concept by solving some numericals. That will help you a lot in your examination. Number one, we will see the first question as two cars A and B are moving as shown in the figure. See very careful here while drawing vectors. Let it is vector A and let it is vector B. Let it is vector B. This is how they are representing. And the angle between these two vectors is theta. Angle between these two vectors is theta. Calculate the relative velocity of A with respect to B. The question is velocity of A with respect to B. That means velocity of A with respect to ground minus velocity of B with respect to ground. And understand very careful or remember the thing is we have seen this one. Whenever I am not representing anything at this point, that is inherently that leads to tells us that is with respect to ground. So velocity of A with respect to B is velocity of A with respect to ground minus velocity of B with respect to ground. Clear? Now here this is velocity of A with respect to ground. This is velocity of B with respect to ground. And this one, what I am doing is now, according to the situation, according to the question is find the relative velocity of A with respect to B, that is VAG minus VBC. And originally VBG, velocity of B is representing in this direction. For that particular velocity, it is positive because car itself is moving in this direction. So it is positive for that car and it is positive for this car A, and we need this is positive only, but this one we need to represent in the negative side. Negative side, that means if it is representing VBG in the positive direction means, can I say this will be minus VBG, and this term is representing like this, like this. Clear? I hope it is very clear. Next point, see if it is the vector, if it is one more vector, resultant will be like this. Resultant. So this resultant is velocity of B or velocity of A with respect to B. Relative velocity of A with respect to B. So velocity of A with respect to B, this is the direction of velocity of A with respect to B. Clear? That means when B is observing A, he feels that A is moving like this, like this. Now, next point, what is the magnitude of this resultant? The resultant magnitude we can find by V resultant is equals to magnitude of A, magnitude of B, 2 of magnitude of A, magnitude of B, and cos of angle between A and B. Angle between A and B. See very careful here. We need this one and this one. So it is actually minus VB, minus VB, right? So angle between these two is 180 minus theta. So this will be 180 minus theta. Clear? Then velocity resultant is equals to VA square plus VB square plus 2VA VB cos 180 minus theta is equals to minus cos theta. Then velocity resultant is equals to VA square plus VB square minus 2VA VB cos theta. This is what is the velocity resultant. Clear? Then next point, see here. Here, next point is this direction is making an angle. Let us assume phi with respect to A. Then that direction value we can find by using the concept tan phi velocity of B sine angle between A and minus B is 180 minus theta, velocity of A plus velocity of B cos 180 minus theta. So the resultant making an angle phi with respect to velocity a vector is tan phi is equals to VB sin theta, because sin 180 minus theta is equals to sin theta only, then VA minus VB cos theta. Cos 180 minus theta becomes minus cos theta, which we have seen just now, right? And this is what is the resultant. Resultant vector makes angle with respect to velocity a vector. This is the first question. Let us go with the second question. See the second question is, and again I am saying, first understand the concept clearly, and after that try to observe how I am doing the problems, and you better to follow these instructions and try to solve these problems without aid from my classes after your observation. Then try to solve your material, that will fetch you a lot of amount of energy. I am promising that. And now, because the questions which we are discussing here are a little bit critical questions. So once you prepare, once you understand these critical questions, you can able to solve easy questions easily, right? That will really helps you a lot in your examination. Now the second question is, a rat is moving down the slant of a wedge of an angle of inclination theta. That means this is angle theta of the wedge, and with a velocity v. So the velocity of the rat is v in the downward direction. Let us assume this is the rat in the downward direction. If the wedge moves left with a velocity u, that means this is velocity of the wedge. Velocity of the wedge, u is the velocity of the wedge. Okay, find the velocity of rat relative to ground. Find the velocity of rat relative to ground. That means velocity of rat with respect to wedge is equals to velocity of rat with respect to ground minus velocity of wedge with respect to ground, right? Then here they are asking us velocity of rat with respect to ground, how much is the velocity. Now, can I say velocity of rat with respect to wedge plus velocity of wedge with respect to ground? And actually, this is velocity of rat with respect to wedge, and this is velocity of wedge with respect to ground. Am I clear? Right? Now, here velocity of rat with respect to wedge is u, right? And velocity of wedge, sorry. Right. Now, velocity of rat with respect to ground is velocity of rat with respect to wedge plus velocity of wedge with respect to ground. Very good. Then, velocity of rat with respect to wedge is here v, v. Now, velocity of wedge with respect to ground is minus u. So here v and minus u. This is the velocity of rat with respect to ground. Here one important point is, this is theta. Actually here I need to do some modifications. Velocity of rat with respect to wedge becomes here, and obviously this velocity will has two components. So this one will be theta, right? This one will be theta. When it is theta means velocity of rat with respect to wedge cos theta component, it will be velocity of rat with respect to wedge sin theta component, this one will be. So velocity of rat with respect to wedge becomes here velocity of rat with respect to wedge cos theta I minus velocity of rat with respect to wedge sin theta j, because it is representing the downward direction, right? Now, of course, they represented velocity of rat with respect to wedge as v. So we can represent like velocity of rat with respect to wedge as v cos theta I minus v sin theta j, right? Let us substitute equation velocity of wedge with respect to ground is minus u. Substitute 2 and 3 in 1 by substituting 2 and 3 in 1, 2 and 3 in 1, velocity of rat with respect to ground is v cos theta I minus v sin theta j minus ui. So this is becomes v cos theta minus u I minus v sin theta j. This is velocity of rat with respect to ground, right? Very good. And if we want speed value, of course in the question they didn't ask. If we want that speed, we can do like this: v cos theta minus u whole square plus v sin theta whole square. This gives speed value. Clear? Then the next point is, see here, b question says if value of theta, find the value of theta, find theta value, if the rat moves vertically downward relative to an observer g fixed with the ground. That means when the observer is observing, he observes that rat is moving in vertically downward direction. Now if observer with respect to ground observes rat moves vertically downward, that therefore the horizontal component of velocity of rat becomes 0, right? That means, see here, this is horizontal component of the rat with respect to ground, so it obviously becomes 0 when the observer is observing that the rat is moving exactly in the downward direction, right? So this term will be 0. This says that therefore v cos theta minus u becomes 0. V cos theta minus u becomes 0. Now here v is equals to, okay, here v cos theta is equals to u, then cos theta is equals to u by v, and ultimately they are asking us to find theta value, so u by v, cos inverse of u by v. This is the answer, right? Again and again I'm saying these are the logical and critical questions. Try to practice these questions before you are going to practice your regular worksheet. You will get an enormous amount of knowledge from these by solving these problems. Then you can easily crack your worksheets easily. First point, if you are very strong in solving your worksheets, obviously you will get good score in your final examination. This is my promise. Clear? Then the next point is, see one more critical problem here. Not critical, along with the not only critical, along with the critical we are discussing logical questions. Actually critical means mathematically we have to do a lot of things, but here we are solving these problems by using some logics, right? Just now we have seen in the rat case, if rat is vertically moving in the downward direction with respect to the ground, means obviously its velocity along the horizontal direction becomes 0. It's a logic in the question. That's we need to understand, and we need to apply the same for the other problems also. Let us see similar problem like this here, which relates to the rat problem, and we see how that concept is again using in this cases. Clear? Right. A truck is moving with a constant velocity 54 kilometer per hour. So velocity of truck is 54 kilometer per hour. That means 54 5 by 18, and this will be 3, and this is equals to 15 meter per second. This is the velocity of truck u with respect to ground. Actually velocity of truck with respect to ground. In what direction should a stone be projected up with a velocity of see, actually there is a problem here. velocity of the stone is representing in the question as 30, and in the diagram they represented it with 20, so we will consider it as 20. Velocity of stone with respect to truck is equals to 20 meter per second, 20 meter per second for a person stand right from the floor of the truck, so as to appear at right angles to the truck, so as to appear at right angles to the truck for a person standing on the earth, right? Now let us see the case as this is velocity of truck with respect to ground, velocity of truck with respect to ground, which is 15 meter per second, and here this is velocity of stone with respect to truck, velocity of stone with respect to truck. Let us assume for our understanding it is making an angle alpha here. Let us assume it is making an angle alpha here, right? Now velocity of stone with respect to truck will have two components. One is vst minus cos alpha I. I am keeping minus negative sign because it is representing from point of starting or origin to the leftward direction. So minus vst cos alpha I plus vst sin alpha j, vst sin alpha j. So this becomes vst cos alpha, and this will be vst sin alpha, right? Now that means this velocity of stone with respect to truck becomes minus 20 cos alpha plus I plus 20 sin alpha j, right? Now velocity of truck with respect to ground is 15 meter per second, right? That is velocity of stone with respect to truck is equals to velocity of stone with respect to ground, velocity of truck with respect to ground. And here velocity of stone with respect to ground is velocity of stone with respect to truck plus velocity of truck, right? Now see here, velocity of stone with respect to truck is minus 20 cos alpha I plus 20 sin alpha j plus velocity of truck is 15, and it is moving in the rightward direction, so we can keep it as I cap. That means velocity of stone with respect to ground becomes 15 minus 20 cos alpha I plus 20 sin alpha j. Now the question is saying, so from the floor of the truck, so as to appear at right angles to the truck, at right angles to the truck, at right angles to the truck means for an observer he is feeling that stone is moving like that, like this. When for observer stone is falling, stone is falling perpendicular, that means stone horizontal velocity remains 0. Stone's horizontal velocity remains 0. Clear? Then 15 minus 20 cos alpha is equals to 0. Then cos alpha is equals to 15 by 20, which is equals to 3 by 4. Then alpha is equals to 53 degrees of, right? Cos alpha is equals to 53 degrees. But they are asking us what is theta value. What is theta value? Right? Here theta means alpha plus theta is equals to 180, right? Then theta is equals to 180 minus alpha, or theta is equals to 180 minus 53. Then theta becomes here 127, 127 degrees, right? This is the required answer. I hope you enjoyed the second question. Then the third question is, and this is one more type of question, fourth question actually, it is fourth question. This is one more type of the question. And this question says a political party has to start its precision in an area where wind is blowing with a speed of 30 kilometer per hour. That is, velocity of wind is equals to 30 root 2 kilometer per hour. And party flags on the cars are fluttering along the northeast direction. That is, velocity of wind is, for a car which is at rest, if flag is fluttering in the northeast direction, means obviously the wind is blowing in the northeast direction only. That's why the flag is fluttering in that particular direction. Right now, can I say here east direction as the I, north direction as J, north direction as J, right? Then 30 root 2, and this is northeast direction, northeast direction. Northeast direction exactly means, can I represent angle as 45 degrees? Can I represent angle as 45 degrees, because they are representing exactly in the northeast direction. So exactly with respect to positive x-axis, it should make 45 degrees. Clear? Then here this velocity of wind will has two components: velocity of wind cos 45, and this is velocity of wind sin 45. Clear? Sin 45. Now can I say velocity of wind cos 45 on I x axis, velocity of wind sin 45 on j axis. Clear? Now velocity of wind is equals to 30 root 2 1 by root 2 I plus 30 root 2 sin 45 is also 1 by root 2 j. This gives us 30 I, these two will get cancelled, plus 30 j. This is velocity of wind. This is velocity of wind. Clear? Now, if the precision starts with a speed of 40 kilometer per hour towards north direction, that is, velocity of precision means the car, velocity of the car is 40 kilometer per hour in the north direction. So I am considering, as per my consideration, north direction is y axis. So I am representing with j cap, sorry, j cap. Then finally, they are asking, find the direction of flags on the cars. Right. When car is at rest, wind is blowing in the northeast direction, so that we directly represented velocity of wind as 30I plus 30J. It's very fine. And when car is moving in the north direction, with the velocity of 40 kilometer per hour, that means in the j axis. Now they are asking, find the direction of flags on the car. Clear? Now first point is velocity of wind with respect to car. Velocity of wind means here velocity of flag. Clear? Velocity of flag with respect to car is velocity of wind with respect to ground minus velocity of car with respect to ground. Am I right? Right? Now when the car is moving, obviously the fluttering will be takes place in the opposite direction to the car, obviously. But originally wind is moving in the north east direction, like this. And and here this is velocity of wind with respect to ground with the magnitude of 30 root 2 kilometer per hour, and this is velocity of car with respect to ground. See here very careful, this is originally velocity of car with respect to ground in the y axis north direction, but here we need minus sign, so that this is the minus of velocity of car with respect to ground. Am I clear? Very good. Right? Now this becomes magnitude under root of velocity of wind with respect to ground square plus velocity of car with respect to ground plus 2 velocity of wind with respect to ground minus, sorry, velocity of, I can redraw this again. Don't worry, I will redraw this. Velocity of car with respect to ground cos, see, negative sign means otherwise this is east north j cap, east I cap, northeast direction 30 root 2 kilometer per hour, 40 kilometer per hour. This is velocity of car with respect to ground, but we need negative sign, that's why we are considering minus velocity of car with respect to ground. So obviously let us assume this might be the resultant direction, and that resultant magnitude, see, let us assume this is theta means obviously this will be 180 minus theta, 180 minus theta, and we know that it is exactly 45 degrees, so this will be exactly 45 degrees, then it will be 135 degrees, 135 degrees, right? Then v is equals to under root of velocity of wind with respect to ground is 30 root 2 whole square plus velocity of car with respect to ground 40 square plus 2 of 30 root 2 40 cos 135. Am I right? Cos 135. Like this, its extension, and this is like this, right? Now cos 135 is equals to cos 90 plus 45, which is minus sin 45, which is minus 1 by root 2. Clear? Then velocity becomes now v is equals to 30 root 2 whole square 40 square minus 230 root 2 40 1 by root 2, oh shit, sorry, root 2 get cancelled, and this will be 900 into 2 plus 1600 minus 1200 2400, right? Then v is equals to under root of 18 plus 16, that is 34 minus 2400, then v is equals to 1000 or 10 root 10 kilometer per hour, right? This is the velocity, first point. And now find the direction of flags on the car. They are asking us to find the direction of the flag on the car. Now let us say, right, let us say this is resultant, this is resultant, okay, let me draw once again. Velocity, sorry, this is eastward direction, northward direction, northeast, minus velocity of car with respect to ground, because velocity of car with respect to ground is like this, and this is velocity of wind. Let us assume this is resultant direction, let us assume this is resultant direction of vw and vcg, right? Then with respect to vw, let us think it is making an angle phi, right? Then tan phi is equals to vcg sin, and angle between these two is 135, just now we have seen, by velocity of wind plus velocity of car with respect to ground cos 135. This is the direction of resultant with respect to northeast direction, right? Then tan phi is equals to velocity of car, that is 40, and sin 35 is equals to cos 45, that is 1 by root 2, 30 root 2 plus 40 minus 1 by root 2, then this becomes 20 root 2 by 30 minus root 2 minus 20 root 2, right? Right? Correct only. Then 20 root 2 by 10 root 2, this is 2. Therefore tan theta is equals to 2. Tan theta is equals to 2. That means with respect to wind direction, the angle of fluttering is tan inverse of 2. Tan inverse of 2. Clear? I hope I explained in a very clear way, right? And you better to follow these classes for your regular understanding the subject. Don't skip any video. Don't try to skip the videos. You have to continuously attend these videos. That will fetch you an enormous amount of knowledge, right? And for daily worksheets and weekend examination papers, you can follow our Telegram channel, Physics with Jagan sir. Have a great day. Take care. Bye bye.